Hello everyone. In this video we are going to see Runge Kutta fourth order method. So it is used to solve it is a numerical technique which is used to solve first order differential equations. So if we see first order differential equations, it is of this form, dy by dx. Okay, so it is similar to Euler's method. In case you want to know about Euler's method, you can see my video. The previous video that I made is the Euler's method. You can check out the playlist for numerical methodologies where you can find out the Euler's method. I'll give the link in the description of this video. So in this particular Runge Kutta fourth order method, it is also used to solve ordinary differential equations. Okay, so here suppose this is our equation. Okay, dy by dx equal to f of xy. So at x naught, at when the value of x is equal to x naught, what is the value of y naught? So this will be given initially, and we will try to find out the value of y at x. Okay, that is the next value of y at x. So here we will try to find out. We will again use this the straight line formula only, x equal to x naught plus h mx plus c. So here we will, instead of finding one single slope, we will try to find out four slopes. So first of all, k1, using this formula, h is the step size. Okay, so initially this is the slope at the beginning of the interval. K2 and K3 interval slopes at midpoints, providing intermediate estimates, and K4 is the slope at the end of the interval. So after finding this value, how we are going to find out the solution? Yn plus 1 will be equal to yn plus 1 by 6, k1 plus 2k2 plus 2k3 plus k4. So this is how we are going to find out the value of y at the next point. Okay, so let's try to solve one problem. So suppose this is our first order ODE. The function is x square plus y square. So when the value of x is equal to 1, y is equal to 1.2. This is the initial condition given. So we need to find out the value of y at x equal to 1.05 using RK method, and h size is 0.05. So this is the question. Now if we see the equation, so first we need to find out one, k1, k2, k3 and k4. So we will go and find that one. So these are the initial conditions given. So first we will compute k1. K1 is how much? H into f of x0, y0. So h value is 0.05. What is x0? Initial is 1, so 1 square, and y is how much? 1.2 square. So how much you got? 0.122. Now you will calculate k2. Again you put it in the formula. So here h value 0.05, x0 is again 1, h by 2 whole square plus 1.2 plus k1. What is the value of k1 we got? 1.122 divided by 2 whole square. So here also you will get some value, right? So similarly you will be calculating. So using this k2 we will calculate, we will get a result. Similarly we will calculate, you see here, this is the calculations given here. Directly I will show it here. So this is k2 value you will get here. If you compute all this, you can skip this part. So directly you will get k2 here. Now similarly you will compute k3 and you will compute k4. Okay, putting all the values of the previous k1, k2 like that. So after putting all this, so what will be the final value of k? The final value of, what will be the final value of y? So y will be equal to yn plus 1 by 6 k1 plus k2. You will put it in the formula. So you already know what is yn. Yn you already know. Then these values you have calculated just now. Yn means the previous value of yn. That is, you got this one, right? This is the value of yn, 1.2. Okay, so the rest of the values, k1, k2, everything you calculated. So simply you put it in this formula to find out the final value. Okay, now we will try to implement this exact thing using C++. Okay, so this is our C++ program. So I have used two header files. One is iostream and one is iomanip. Okay, using namespace std. Okay, after writing this, we will straight go to main part. Okay, so inside main, what are the variables I have taken? The initial value of x. So when the initial value of x is 0, the y value is 1, right? Then x, that is the point at which we want to estimate the value of x, 2. Okay, and age, that is this one point, the step size the step size is, we have taken it as 0.1. Okay, then double result, the result, for the result we are calling this function Runge Kutta 4. Using this, we are, what arguments we are passing? x0, y0, x and h, and whatever result it will return, it will be stored in result variable. And finally we are displaying the result variable here. The value of y at x equal to x is approximately this result. Okay, so now we need to go to this particular function. Let's go. Okay, so this is our function double, because we are going to return a particular value, this function. So these are the arguments as I have mentioned. Okay, initial value of x, y, then x, for which we want to find out y, and h is the step size. Now we want to know, after getting this data, we want to know how many intervals will be there, right? This value n represents the interval. So we are going to do it using this formula. What does this formula means? X minus x naught divided by age. Why? Because if we see this, let me explain with the help of a diagram. Suppose this is the function. Okay, so suppose x naught is present here. Okay, x naught. So suppose, and the final value of x, for which we need to find out the, here we have y, this side we have x. Okay, so suppose we want to approximate the value of y when x is equal to this much, right? This is the value of x, this is the value of y naught. Okay, so this point we want to know. So for that, we know that the step size is equal to h. H means we are going to each interval, the step size will be h. Then how many intervals we will need? X minus x naught divided by h will give the number of intervals that we want. So what is the value of x in our case? If we see here, the value of x, I guess we have taken it as 0, 0, y value is 1, x is 2, right? H is 0.1. So if we see it, then what we will get? X value is 2 minus x value is 2. Then we need to find out x naught. X naught is how much? X naught is 0, right? X naught is 0 divided by 2. The step size is 0.2 or 0.1. Let me check. Okay, the step size is 0.1. So if we see 2 minus 0 divided by 0.1, we will get 20. That is, the whole space will be divided. If we see this one, this whole area will be divided into 20 spaces, each of with 0.1. Step size is 1, right? So now this one I just added to show the number of intervals. Let me delete it, this one. So now we will have to calculate k1, k2, k3 and k4. So initially the initial value of y naught, we will put it in a variable y. Okay, so here we have just divided, that is the number of for the first interval, then second interval, like that we will enter. So now when I equal to 0, I less than 20, we are going to enter the first interval. So in the first interval, we are going to calculate the value of k. So we are just simply putting it in the formula. If you see, this is the this one we don't need. Okay, so this is the formula, k1 equal to h into f of xn. So we are just k equal to h into dy by dx, that is the function x into y, xn, yn means xy. Okay, so h value we know 0.1. Then the function is which one? We are calling this function dy by dx is the name of the function, and we are passing the values. X naught is how much? 0, and y is how much? 2, right? Sorry, 1. How much it is? Yes, 1. So we are going to pass 0 and 1 and we are going to find out this particular value, return x minus y, because this is the function. Okay, the function is dy by dx is equal to x minus y. So this is the function we are using. So whatever is the value, it will be returned. Like that, we are going to calculate k2, k3 and k4 using exactly these formulas. Okay, so we will calculate all these values like this. Okay, then we will find the value of y. So if we see the formula, what is the next value of y is equal to old value of y plus 1 by 6 into these things, right? So we are simply going to y equal to y plus this part we are doing. Okay, y, what is the value of y? Y we already know, it is the first time when we will run the loop for the first time. Obviously we are going to take the initial value as the old value, right? So we will use this to get the new value of y, and after that we need to increment the value of x. So if we see the diagram, we started with this point, right, x0. Now we will go to this point, x1. So x1 is how much? This part is h, this size is h, right? So that's why we are writing x0 equal to x0 plus h. That is the next x value we are going to do. Then again we will increment the value of I. Now we will be in the second interval. So like that we will perform all the 20 intervals to find out the value of y. Okay, so ultimately we are going to return this value y, and it will be displayed as a result here. Okay, so let's run and save this program, and let's compile and run how it looks like. So the value of y at x equal to 2 is approximately this value. Okay, so you can write down the program and see whether you are getting this value or not. So this is all about Runge Kutta method. Thank you everyone.